In this video, we're going to look at measures of the center of the data. It's 2.5 in your textbook. We will look at the measures of central tendencies, average, median, mode. Most people are familiar with average. Just add up the numbers, divide by the total number of values. But we want to look at whether we're analyzing central tendencies of populations or of samples. We also want to look at the center of the data as a way of describing location. So mean and median are very commonly used. There are some other things that we'll look at as well. So one thing just to recall, parameters are what we get when we the population parameter is what we would refer to when we're crunching numbers, finding like the average. It would be a parameter, and we are going to use this little Greek letter here. Looks like a U, but it is the Greek letter mu. Statistics are often used as X bar. This line should be actually like right on top of there. Okay, so I went ahead and fixed that. So we're going to look at an example here. Arithmetic mean is just what we were talking about. Add up the numbers, divide by total number of observations or data values. Example 2.15, I think you could go ahead and figure that out on your own. We're just going to look at these travel times in minutes to work for all 7 employees at a startup web development company. We have 23, 36, 23, 18, 5, 26, 43. So go ahead and compute the mean of this data, round the answer to the nearest hundredth. A lot of times it's just one more place than the data is given in. So we could go to tenths, but they specifically ask in this problem to go to the nearest hundredth, which sometimes that might happen in your MyOpenMath. So we'll go ahead and leave that as is. So go ahead and figure that out. You can use Staplet, would be pretty quick and easy, just putting it in your calculator and adding it up and dividing. Just be careful, make sure that you hit equals before you hit the division or use parentheses. So I'm going to put the numbers in GeoGebra and Staplet just for sake of practice. So I would have to click in the box, and I'm going to actually just type it in, because when it's in a list like this, it doesn't work well. You can't paste it in. It doesn't paste right. It has to be like in a column when you're doing GeoGebra. So I'm going to just go ahead and type these in, and then we'll look at the comparisons here. I'm going to make this a little bit larger. And then another thing that's weird with GeoGebra, it doesn't erase like your stuff. Even if once you get rid of your previous data, it'll still show like the picture of the box plot you can see there. So just make sure you really do highlight the new data, and then I'm going to click show statistics. I'm also going to do one variable analysis here so I have the right box plot, and then you can kind of drag these things over to make it look a little better. And you can see here we have the mean 24.8571. Here's the population standard deviation, the sample standard deviation, and my 5-number summary is all right there. We're not going to use these other things. Sigma x and sigma x squared are used for formulas. We're not using the formula method at all. You'll see it in your book, but we're not going to be using that. Okay, so the average is 24.857 is that value. So and that would be the mu because it's the population. So I'm going to go ahead and insert that in here. Well, it capitalized it for me, which I don't want it to do. is. And we would write our answer in a sentence. The average travel time to work for all employees is 24.86 minutes because it said to round to the nearest hundredth. So just to add that in, we didn't round it yet, but in the final answer we did. So the next example, 2.16 or 2.16, we're going to take that same data here and we are going to use the random number generator just to get a sample. So we're going to compute the sample mean. Obtain a second simple random sample of n equals 3 employees, again do the mean, and then round and compare. So what I'm going to do is just number these. I'm going to leave them in this order. I'm not going to reorder them or anything, but 23 is my first value, and then 36 second, and so on and so forth. And I'm going to look at that random number generator. I'm going to grab that. I don't know if it's, I think it's a different one than I showed you before, but I just searched random number generator and came up with this, or you could use that link that we used before. And basically I'm not putting in what the actual values are. I'm just putting in how many. I want to have a first to the 7th, and I want to get a list of 3 at a time, no repeats. So I'm going to go ahead and just hit calculate here, and I get 4, 7, 6. So I'm going to pick the 4th value, which I have as 18, and then I'm going to pick the 7th, which is 43. Oops. And then the 6th is 26. Okay, and that's pretty easy to add those up and crunch the numbers by hand. I would get, well, go ahead and do that with me. 18 plus 43 plus 26 is 87. Divide by 3. And I get 29. And it's saying to round to the hundredth, so we could say 29.00. And then the next set, they want you to do it again. So I'm going to clear, and then I'm going to, I don't know if I needed to clear that whole thing, but I'll just put it in again. I'm going to generate 3 at a time and calculate. I should be able to just hit it again and do it, but so this time I get 5, 7, and 1. So 1, 2, 3, 4, 5. So that would be actually the number 5, just by chance. And 7 is 43, and 1 is 23. So it's just random pick of numbers, and then go ahead and crunch those numbers. And I get 71 divided by 3, and that's 23.666, so on. So 0.67. So just to give you an idea of how they come out and how they're different. And this one we would call X bar, or label it as X bar. And if you want to know how to type that in, I'll put that over here. I'll show you. We can go to insert and then equation, insert new equation, and then we go up here where it says accent. See this A with the dots, click on that, and then if we go 3 rows down and 1 column over, if you hover you can see it says bar, and then we would just put the X in there, and that's X bar. And then I'm just going to put an equals there too. And then for the next one, we can just Control C, and Control V and put our equals. So you can see how it's different. We had 24.86 for the population, so that's the most accurate because we used all that. There's only 7 employees, so that does count as population, and that's a parameter. Our statistic is a sample, and that is going to be notated by X bar, and we did a random generator to pick three of the values, and got 29, which is quite a bit higher, but the 23.6 is pretty close. Now, if we kept going with this and we randomly generated another group of 3, got that average, another group of 3, got that average, and then we average, those together and stuff, then we will be pretty close to the population. Later in the course, you'll see more about that and how we have those repeated if we take sample after sample, and the means of the samples or the proportions we'll look at as well. So that is it for example 2.16. Now we're going to look at the median for the data. Now, because we're using the software, we're just going to have that all set up for us. And if we go back and look, it's quite nicely there for us. We have this 23 is our median. Let's check GeoGebra, make sure, see if it matches up. Yep, 23. Some things might be a little different. For example, Microsoft Excel can sometimes be a little bit different. So if we want to write the median, we can insert equation. We can do the accent again, but in this case, we want what's called a little tilde, and that's how we notate median. And then we could say the median time is 23 minutes for all employees. We can then look at a couple of different scenarios and see what's going to happen if we change some things around, like if we do have an outlier or something. So suppose an example 2.15, we have that same data set to start with, but now we're going to change it up. We have a new employee, and their time is 70 minutes. That's quite a bit further. So let's see what happens if, now we are using that. So we're adding that person in. What's our average going to be? So let's go ahead and pop that in. So I'm going to use Staplet because in this case it's a lot easier than typing it in. I really like Staplet's, like really nice and quick. Begin analysis. I don't even need to look at the graph. I just want that mean. So now our mean is 30.5. Okay. If we did look at the box plot though, let's check it out. It is saying that's an outlier. Okay. And you can look at what the median is though. The median is 24.5, but the mean is 30.5. So let's go ahead and jot that down. So this is saying the median, actually asking for the median, but I want to point out the mean as well. So I'm going to write that down here. So the mean is, what did I say? It was 30.5. And the median is 24.5. I'm going to go ahead and put those in red for you. Okay, so if we look at a comparison, the median for our population was 23 minutes for all employees when we had that first data set without the 70, and we add the 70 in and we're 24.5. It's not that much different. It's kind of holding steady, you know, like pretty similar. And then, but the mean jumped up a lot. So we have the mean, that's our sample one, but our mean was 24.86, and now it's 30.5. So 24 to 30.5 is pretty different. So there's something we call resistance, that if a numerical summary of data is said to be resistant if extreme values, very large or small, relative to the data, do not affect its value substantially. So in this case, it seemed like median was more resistant. Let's try again. Why don't you guys go ahead and do that? We're going to add in another person and we'll take this same data set and we're going to add in the 130. So now we have more employees, and we're going to just copy and paste that into the to Staplet. So go ahead and pause the video and do that and see what you get for mean and median. Now this is interesting. I popped that data into Staplet. So now I have 9 employees total. My mean is 41.556. You can see this standard deviation number, which we'll talk about next, but the other values here maybe changed a little bit. The median is 26, so that's still not too far off, but our outlier now is 130 instead of the 70. The 70 is within the fence. So again, we don't ever draw the fences in, but and we could figure out exactly what they are using that formula we talked about in another set with the interquartile range. We just take Q3 minus Q1 and multiply that by 1.5, subtract it from Q1 to get the lower fence, and add it to Q3 to get the upper fence. We're not going to do that now. The computer does it for us, but the outlier is 130 and 70 is not an outlier in this scenario. But that 41.56 for mean is substantially more than originally, and the median is not. Okay, so we have mean is 41.56 and median is 26. So we could say the mean is affected or impacted by the new value. Median is not affected much. So that's an important concept right there. So that's why a lot of times they'll give you for house prices, other kinds of things, we use the median instead of the mean because it's more resistant. And there's that definition again. Example 2.19, following data represent the travel times in minutes to work for all 7 employees of a startup web company. So this is the original set. Another central tendency is called the mode. So the mode can be computed for quantitative or qualitative data. So that's really nice. It's very helpful to us to have that. And it's the most frequent observation of the variable that occurs in the data set. So it may have no mode, one mode, more than one mode. If no observation occurs more than once, we say the data have no mode. So one thing that is helpful for this is to put it in order. So that's what they did here, this set. So we can clearly see that 23 happens twice and no others happen more. So we would say the mode is 23. Okay, so we could talk about that here. The mode is 23 minutes. So if it's a really small data set, it's easy enough to just, look at it and do it by hand. But if we have larger sets, we want to use probably, I think Staplet would work best for this. Let's try that one. What is the mode for the weights in pounds of the 10 students in the nutrition class? So we have this data set: 95, 117, 210, 154, 193, 117, 130, 133, 268, 145. So I'm just going to go ahead and copy and paste into Staplet. So I have my previous one there. I got to get rid of that. And then I'm going to pop in my new data set, begin analysis. So the dot plot is a really nice way to see the mode easily. I think that may be the best way. And I just want to make this big so we can make sure we're looking at the whole thing, because you can see how they stack up. Another one I think would be, well, let's see, histogram maybe. It doesn't really tell me each individual one. It kind of tells me the clusters where, see, the dot plot will show me a little bit better. Stem plot, again, it doesn't quite give you the full layout of it in the same way the dot plot does. Each individual exact same value. It kind of clumps it. So you can use a dot plot. GeoGebra would do that as well. So in this case, the mode is 117. You could also just eyeball the data and see it there. I just wanted to show you how you can find it if it's, larger data set and you don't want to necessarily be trying to count them all up. Here's one with colors. And I always answer, with units. Oops, I'm stuck on minutes already, but it was pounds. So I'm going to go ahead and copy and then paste. And you do that with B. And on this one, I'm not putting in all the titles and everything because I'm just really looking at it to answer a question. Okay, group 1 has non-numeric values. So my mistake there was I have to go back to menu and I have to do categorical variable. single group. And then I don't want it counts and categories. I don't have it already in a table. I have it as raw data. So I can go ahead and click in the box and paste my colors in. Okay, so just be aware of that. If it gives you a flag, then go back and make sure you're in the right thing. And here I want bar chart, works just fine because they're categories, blue, green, red. And then I can hover to make sure I get the exact amount. So blue is 5, green is 4, and red is 5. So I have 2 modes, so red and blue. So it's bimodal, red and blue would be the answer. Okay, so here's the answer for that. Just the modes are red and blue. The data is bimodal. Okay, next we're going to look at calculating the mean of a frequency table. We've done this, I believe, before. I showed you in GeoGebra. So go ahead and try that one on your own, and I'll put up the answer. See how you do with it. I think you can copy and paste into each column of GeoGebra. That'll make it easier for you. So hopefully you've paused the video and you're working to get this problem done here. So we have the weight in pounds. I've already copied and pasted that into GeoGebra. So I'm going to show you this one. I just go up the column. So I'm clicking and holding my click and then highlighting this. And then I'm going to hit Control C to copy. And then I go into GeoGebra and I'm going to click in the corner here in this column, the top of the column, so not the corner, that's the one I did before. And then I hit Control V and it will put all the values in for me. So you can see a little better there. And then I have to highlight both columns and click this little icon of the histogram, and then I'm still doing one variable analysis. We're not doing 2 variable regression or multivariable anything yet, because it's just the one variable of the weight. It's just that it's put in a frequency table. So that's why GeoGebra is easier to work with on this. So I'm going to hit one variable analysis, and I have a box plot there, and I also can find all my data values. And what I was asked in the question was to just find the mean. So we're just going to look at that. Okay, so you should be getting 106.0625 pounds. If I'm rounding, one more data value, or one more value than the data is given in, it would be 106.1 if I'm rounding. The next one here, I'll let you go ahead and do as well. Same kind of thing. We're going to also look at the median for this one. So if you have a range here, the class widths that we're looking at before, like for histograms and such, in order to find the mean and median of these grouped frequency tables, you would use the midpoint. So you can go ahead and copy the midpoints up, copy the frequency, and put them in. I'm going to see if I can just do both at the same time and get that into GeoGebra. Again, do this along with me. First thing I need to do is go ahead and click in here and hit delete on my keyboard is what I was doing. Let's see if I can get the whole thing to delete. I'll just cut it out. And then here, if I go ahead and click Control V, and it looks like it's a little bit off when I do that, because it should be Let's get that set up here. Didn't copy paste it incorrectly, so I'm going to do it again, just one column at a time. Control C, and then I'm going to get rid of these. Click in that one square, hit Control V. It's a little fussy like that sometimes. Get rid of those, and then I'm going to do this. Control C, and then click in one square at the top of the column I want, hit Control V, and then it did it just nicely. So then I go ahead and highlight both. And again, you can pause the video and just fast forward as you see fit, as long as you're able to get them done and turn in your notes, take pictures, screenshots, draw it out, however you want to convey to me that you've done this. We're going to click one variable analysis. And again, we were looking for mean and median on this one. So let's just make sure that went through, and then I hit the mean or the data thing for statistics, the sigma x, and then my mean is 304.44. This is for the cost of textbooks, so that's $304.44, and the median is $320. And just to note some other statistics here, we have the population standard deviation, and the sample deviation is S. So we're going to look at those next, but just so you know, the measures of variation are right here. So those are the answers we're looking for here. You can also see the box plot and how the data looks, and the spread of the data is shown there a little bit. We could use it as a histogram, because midpoints are really good for histograms. We can show that. And here's a bar chart, but that isn't really the best choice. I wouldn't say a bar chart for anything like money problems and stuff like that. Histogram or a box plot would be better. Histogram, I think, is the best for this. And then you can see that chunk there too, that 300. It's really quite a bit. Okay, so here's your answers right there. In the next video, we're going to look at 2.6, skewness, and the mean, median, and mode.